Hi friends, in this video we are going to solve this problem. So here I will explain this problem with the help of both. One is with the help of vertical strip method and one is with the help of same problem I will solve once with the help of vertical strip method and with the help of horizontal strip method. So here I will explain how to find. So here first of all just here evaluate the double integration e to the power ax plus by dx dy over the region bounded by x equal to 0, y equal to 0 and the line ax plus by equal to 1. So here this is my line x equal to 0. So here and y equal to 0 and third is ax plus by equal to 1. So this is my line L and here I will write this same as x by 1 by a. Here x by 1 by a becomes ax. Here y divided by 1 by b which is equal to 1. So this indicates that my line L intersect at x axis at 1 by a. My line L intersect at y axis at 1 by b. So here just find, so just first line is L1 x equal to 0. This is my L2 line y equal to 0 and this is my line ax plus by equal to 1. Line L3, that is L3, intersect at x axis 1 by a, at y axis 1 by b. So here I will draw the region here. So let's say this is my y axis, this is my x axis origin. So let's say this is my x axis, let's say this is my y axis. Now here x equal to 0, here the value of x equal to 0 along the y axis. So here complete y axis, here along the complete y axis the value of x equal to 0. Let's say this is my x equal to 0 and here line y equal to 0. So here along the x axis the value of y is 0. Just focus here, ax plus by equal to 1. This is same as x by 1 by a plus y by 1 by b which is equal to 1. So here I will take, let's say this is my coordinate 1 by a. So here this is my x coordinate and along the x axis the value of y is 0. So here I will take y coordinate as 0 here. In the same way this line intersect at y axis with 1 by b. So at 1 by b. So here let's take, here I will take 1 by b. So here along the y axis x coordinate is 0, here x coordinate is 0 and the value of y is 1 by b. So here I will consider this is a and let's say this is my b. So here this is a and b. Here first I will draw the line which join these 2 points a and b. Now here this is the straight line which joining a and b. So with a coordinates are 1 comma 1 by a comma 0, b coordinates are 0 comma 1 by b and here x equal to 0. X equal to 0 means along the x axis. So here I will consider this line here from 0 to b. Here I will consider this is x equal to 0 and from 0 to a. So here I will consider this is y equal to 0. Now evaluate this integration of this function over the region bounded by x equal to 0 means x equal to 0, y equal to 0 means here y equal to 0 and the line ax plus by equal to 1. This is my line here, this is my line ax plus by equal to 1. Now here I want to use, here I want to cover this region, here I want to find the accumulation of this function over this region OAB. So here in the other word I want to find the effect of this function over this region. Effect of this function, that is e to the power ax plus by dx dy over effect of e to the power ax plus by over this region triangle OAB. Now here I want to cover this region to find the total accumulation of this function over the given region triangle OAB. So here first I will use the vertical strip method. I want to cover this region with the help of one strip. Here first I will draw one strip. Let's say this is my strip. Here I want to cover this whole region OAB with the help of this strip. Let's say this is my strip C and D. Let's say this is my strip C, D. Here I want to move this strip here in this here direction. Here I want to move this strip so that to cover the whole region OAB. So here while moving this strip, let's say this is my strip CD. While moving this strip CD to cover the whole region, the one end of my strip CD is fixed along the x-axis. So here from 0 to A, and the other end of my strip CD here terminate on this line ax plus by equal to 1. So here the lower end of my strip, let's say CD, this is the lower end of my strip and this is the upper end of my strip, and the lower end of my strip here start from x-axis. So here at x-axis y equal to 0, and the upper end of my strip terminate on this line x plus by equal to 1. So here at this point the upper end of my strip with value of y is different, at this point value of y is different, and at this point value of y is different. So here first I will find, let's say this is C and D. So here I want to find the value of y at this point. So here I want to find the general value of y so that we satisfy the all point. Here at this point value of y is different, this point value of y is different, this point value of y is different. So that here I will find the in general value of y, so which satisfy for all the point along this line ax plus by equal to 1. So here y equal to, here I will find the general value 1 minus ax divided by this is here divided by this is b. So here this is the general value of y along this line ax plus by equal to 1. Now just observe one thing. Here my strip CD start from x-axis, on x-axis y equal to 0 and terminate on this line ax plus by equal to 1. So here at each and every point the value of y in general form 1 minus ax by b. Now here x limit height along the x-axis. So here x limit height along the x-axis. From here to here height is different, from here to here height is different, from here to here height is different. But here in general 0 to 1 by a. So this is my x limit. So here x limit is x equal to here along the x-axis x equal to 0 to x equal to 1 by a. X equal to 0 to x equal to 1 by a. These are the x limit of my region, and here y limit equal to, here my strip start at x-axis. Here on x-axis y equal to 0 to my strip terminate on this line ax plus by equal to 1. The value of y on this, the general value of y on this line is y equal to 1 minus ax by b. Now according to this limit my integration is, so here according to this limit my integration is, here according to this limit e to the power ax plus by. Now here when my strip is parallel to y-axis, first integrate with respect to dy. So here whenever your strip is parallel to y-axis, first integrate with respect to dy and then dx. Now here put the y limit and here put the x limit. Now tell me the limits of y equal to 0 to 1 minus ax divided by b. Now put the limits of x. So here x equal to 0 to x equal to 1 by a. So we have to evaluate this integral. So here when your strip is parallel to y-axis, in the same way, now here I want to cover the same region with the help of horizontal strip which is parallel to x-axis. Now here let's say this is my same region. So let's say first I will draw here the region. So here let's say this is my region. Here a 1 by a comma 0. Let's say this is b coordinate 0 comma 1 by b. Now here this is y equal to 0 and this is x equal to 0. From here 0 o to b, x equal to 0, from o to a, y equal to 0, and this is my line ax plus by which is equal to 1. Now here I want to cover this region with the help of, here let's say I want to cover this region with the help of horizontal strip which is parallel to x-axis. Let's say here I will draw one strip. Let's say this is CD. Here this is C and D. I want to cover this region with the help of this strip CD. Now here my strip CD one terminal of my strip CD fixed on this y-axis, y-axis here along the y-axis x equal to 0, and the other terminal of my strip CD here terminate on this line ax plus by equal to 1. Now here along the x-axis, height is along the x-axis. Now here find the value of x, find the general value of x to this line. So here at this point value of x is different, at this point value of x is different. Here I am saying at this point height of my strip is different, at this point height of my strip is different, at this point height of my strip is different. So here the height of my strip is completely based on the value of x. Here means this terminal. So here where your strip terminate. So here if your strip start at this point and terminate at this point, so here the height of your strip is different. So here along the x-axis, at this point height of your strip is different, at this point height of your strip is different. That's why first I want to find here, this is y-axis x equal to 0. Now I want to find the value of x which satisfy the each and every point. So here I want to find the general value of x for this line ax plus by equal to 1. So here I want to find x equal to 1 minus by divided by a. So here x equal to 1 minus by divided by a. This the value of x satisfy along this line ax plus by equal to 1. So here this is the general value of x for this line ax plus by equal to 1. Now I want to find here, I want to cover this whole region OAB. So here I will move this strip at this point, I will move this strip at this point, after that I will move this strip here at this point, this point, this point, this point, to cover the whole region of triangle OAB to find the total effect of my function e to the power ax plus by over this given region. Now here with respect to horizontal strip, find the limits of x and find the limits of y. Now tell me here limits of x means value of x here along the x-axis, here x equal to 0 and terminate on this line. So here limits of x start from y-axis, here x equal to, and along the y-axis x equal to 0 to x equal to 1 minus by divided by a, and the value of y, here my strip move along the y-axis at 0 to this point. At this point the value of y is 1 by b. So here value of y equal to here 0 to y equal to 1 by b. So here according to this limit, the double integration of my function e to the power ax plus by, here I am using the horizontal strip which is parallel to x-axis. Whenever you are using horizontal strip which is parallel to x-axis, first integrate with respect to dx and then dy. Here I am integrating with respect to x. First I will write the limits of x. Here limits of x are x equal to 0 to x equal to 1 minus by divided by a, and the limits of y, here integrate with respect to y, limits of y equal to 0 to 1 by b. So here either use this method to evaluate, to find the accumulation of this function over the region OAB, you will get the same answer, or with the help of horizontal strip, or you can use the vertical strip which is parallel to y-axis to find the total accumulation of this function over the region OAB with respect to this limit. So here just one thing, remember, whenever you are using the vertical strip which is parallel to y-axis, first integrate with respect to y, put the limits of y, then integrate with respect to x with x limit. Here I am integrating first, here I am using the horizontal strip which is parallel to x-axis. So first integrate with respect to dx with x limit in y variable, and then integrate with respect to y with y limit, they are constant. So here whenever just here, for example, in some example they will give the limits. So here you have to just find the order. So here whenever inner limit in terms of x variable, integrate first with respect to dy and then dx. Whenever inner limits in terms of y variable, at that time integrate first with respect to dx and then dy. Now here I will solve this example with the help of horizontal strip method. So here now I will solve this example with the help of horizontal strip method in starting. Now So here first of all we have to write the region of my integration. So here now I am start writing the answer. First identify the region of my integration. So here the region of my integration is the triangle OAB. So here the region of my integration, the region of integration, the region of my integration is triangle OAB. So this is the triangle OAB. So OAB, this is the region of my integration. Now this is my first step. Now second step, the working rule says, first step, find the region of my, identify the region of my integration. The region of my integration is the triangle OAB. Second step, to find the point of intersection. Here in the graph itself, here I find the point of intersection. Again no need to find. So here now I will directly say, here draw vertical strip or horizontal strip. Here next step says, next step decide whether you are using vertical strip method or horizontal strip method. Whenever you are using vertical strip method, so here whenever you are using vertical strip method, first integrate with respect to dy and then dx. And whenever, here let's say this is your xy plane, whenever you are using, so here this is vertical strip method. Whenever you are using horizontal strip method, so here first integrate with respect to dx and then dy. Just observe one thing. Whenever you are using vertical strip method which is parallel to y axis, at that time integrate first with respect to dy and then dx. And whenever you are using horizontal strip method which is parallel to x axis, at that time integrate first with respect to dx and then dy. So here this is the way. Now here in this example, here I am using the vertical strip method which is parallel to y axis. First I will integrate with respect to dy and then dx. Now the region of my integration is the triangle OAB. Now second thing, here draw a vertical strip. Draw vertical strip, let's say CD, which is parallel to y axis. So this is the, here draw the vertical strip CD which is parallel to y axis. Now start from here, vertical strip parallel to y axis. Start from here, my vertical strip start on x axis and terminate on this line. Start from x axis and terminate here, terminate on line. Where is the line? Line ax plus by equal to 1. So here my vertical strip start on x axis and terminate on this line ax plus by equal to 1. Now here third step is find the limits of x and limits of y. So here limits of x. So limit of x. Now tell me limits of x. Here my strip, vertical strip move here in this direction. Here horizontal, here this is the horizontal movement. Here I want to cover this whole region, triangle OAB. So here I will move this strip from O, here from OB to this point, OB to this point. Here the movement along the x axis start from x, the x limit means movement along the x axis 0 to 1 by a. Here limits of x start from x equal to 0 to x equal to 1 by a. Limits of y, here limits of y equal to, here limits of y along the, here height along the y axis. So here start from x axis, here y equal to 0 to terminate on this line ax plus by equal to 1. The value of y on x axis is 0 and the value of y corresponding to this line ax plus by equal to 1, y equal to 1 minus ax by b. So here value of y start from y equal to 0 to y equal to 1 minus ax divided by b. Therefore the limits e to the power ax plus by d, here dx dy, which is equal to, now therefore now here first here I directly write, here I will integral. Therefore I equal to, here I am using the vertical strip which is parallel to y axis. So here first I will integrate with respect to y and then x. So here e to the power ax plus by. First integrate with respect to dy and then dx. Here I am integrating first with respect to dy. Here I will write the limits of y. So here y equal to 0 to y equal to 1 minus ax divided by b. Now after that integrating with respect to x. So here I will write limits of x. X equal to 0 to x equal to 1 by a. This is dy dx. Now here first I want to integrate first with respect to dy. So here ax is constant. So here which is equal to here 0 to 1 by a e to the power ax into e to the power here 0 to 1 minus ax by b e to the power by. This is dy and then dx. Now here e to the power integration of e to the power ax equal to e to the power ax divided by a. So here derivative of exponent with respect to here this is dx. Integration of e to the power ax dx equal to e to the power ax by derivative of exponent with respect to x. So this is a. So here in the same way integration of here which is equal to here 0 to 1 by a e to the power ax. Now integration of e to the power by with respect to y integration. So here this is equal to e to the power by divided by b. So here e to the power by divided by derivative of this exponent with respect to y. So from limits start from 0 to 1 minus ax divided by b, and this is again with respect to dx last. Now here so here I will take this b constant. So which is equal to I equal to here 1 by b. Here I will take this b constant outside the integral. So here 0 to 1 by a e to the power ax. Now here upper limit minus lower limit. So here e to the power here e to the power b times. So here value of y 1 minus ax by b. Here 1 minus ax by b. Here minus. So here lower limit e to the power b times 0 e to the power here b times this is 0. This is again with respect to dx. So here which is equal to so here 1 by b 0 to 1 by a. This is e to the power ax. Now here b gets cancelled. So here e to the power 1 minus ax and minus e to the power 0 is 1. So this is 1. This is dx. So here which is equal to so here I will multiply this e to the power x 1 by b times here 0 to 1 by a e to the power here 1 minus ax. This is plus ax. This is minus e to the power ax. Here I am multiplying e to the power x to this bracket. So here first e to the power 1 minus ax plus ax. So here multiply this minus e to the power ax. This is dx. So here which is equal to 1 by b times. So here x gets cancelled. This is 0 to 1 by a e minus e to the power ax. This is dx which is equal to here 1 by here b times. So here integration of e with respect to x. So here ex minus here integration of e to the power ax. E to the power ax divided by a. Limit start from 0 to 1 by a. Now here which is equal to 1 by b times. So here upper limit minus lower limit e 1 by a minus e to the power a 1 by a divided by a minus. So here 0. This is e times 0 minus e to the power here a times 0 divided by a. Now which is equal to 1 by b times. So here this is e by a. Here a gets cancelled. This is e by a minus. So here this is 0 minus minus this is plus. So here e to the power a into 0 0. This is 1 by a which is equal to here this gets cancelled. Which is equal to 1 by b times 1 by a which is equal to 1 by a b. So here this 1 by ab indicates the total accumulation of my function e to the power ax plus by over this region triangle OAB. In this way you can solve whenever your limits are not given in the question. So here we have to identify this limit with the help of this region. Here I am using the vertical strip CD which is parallel to y axis, start from x axis, terminate on this line ax plus by equal to 1. So here my vertical strip movement here bounded by here along the x axis, start from this and terminate on this line. So this is the x limit. So x equal to 0 to x equal to 1 by. So here this is the x limit and limits of y. So here along the y axis, so here the height of this strip depends on this line. So here at this point value of y is different, this point value of y is different. So here I will find the general value of y which satisfy for all the point along this line ax plus by equal to 1. So here this is the line ax plus by. So value of y equal to 1 minus ax by b. So here just take right hand side, by equal to 1 minus ax. After that take b in the denominator to the right side. So here limits of x, then vertical strip, first integrate with respect to dy. So here also you can observe one thing. Whenever inner limit depends on here vertical strip which is parallel to y axis, integrate first with respect to y. At that time limits of inner integral is in terms of x variable. So here, and if I use the horizontal strip which is parallel to x axis, at that time the value of x in terms of y variable. First integrate with respect to x and then y in this way. So here, but this final answer indicate that the effect of this function e to the power ax plus by over this region. So here in this way you can solve any problem. So here with this is the answer. I hope all of you understand. Thank you.